everybody. Welcome back to Coding Nomads Tech Talks. My name is Ryan Desmond. I'm a co-founder of Coding Nomads, and today I'm speaking with Julian Medina. Julian is a software. Hi, Julian.
Hi, how's it going, guys?
Julian is a software engineer. Works in Python, lots of cool stuff: data science, machine learning, software development for a company down in Austin, Texas, and is working with some really interesting clients and doing some really cool stuff. And it's a pleasure to have you here, Julian. Thank you.
Oh, thanks, Ryan. Yeah, thanks for having me on.
Nice. So what are we going to chat about today?
Yeah, no, I was hoping to sort of just give a general introduction to Docker. I feel like it solves a lot of good problems, and I think it can be helpful to anybody, not necessarily even just people doing software professionally, but even just every project or any person that wants to mess around with it.
Nice. So what is two questions. One is, what is the audience kind of for this chat? And then the follow-up question will be kind of to get it started, what problems does Docker solve?
Yeah. So I wanted this to be really sort of, upper high level for everybody. So, I don't want you to feel like you have to be a software engineer and have gone, to 4 years of college or anything like that. You don't have to have a master's degree. I want anybody to be able to come into this and sort of be able to dig your hands into Docker really quickly to sort of get your project up and running without having to have all the nitty gritty details of the lower level stuff.
Nice, cool. And so that kind of leads into the next question, which is what problem does Docker solve?
Yeah, and actually I have a few slides if you don't mind me saying,
Sure.
but I'll share my screen. Perfect. Yeah, so the main idea of Docker is, when we have very simple and small projects, so it's very easy to sort of give that to another person, right? If I wrote a script for Ryan that pulls his emails on a daily basis and maybe gives him a notification, it's really simple. Yeah, I can put that in one script. But as we start doing a lot of complex things, scraping the internet, and I take that and I push that to some API, and I do a lot of crazy things, we start building this, really complex, web of dependencies and things that need to interact with each other, services, and a lot of things that are just really hard to maintain and hold together. And then also, how do you keep that from interfering with your regular system? So you have Linux users, they use Python on their regular system. If anybody's had to deal with dependencies that have messed with their system's Python, it can create a whole host of issues. So the idea behind Docker is we want to put essentially this really complex system into a box. We want to package it up. We know that it has everything that it needs to operate within its own box. And then I can give that to Ryan rather than tell him, here's all these complex things. You're going to need this. You're going to need dependency A, B, and C installed on your computer. I can just hand him this box and I know it's going to work. So it's sort of gone are the days of saying, well, I know it worked on my computer, so I'm not sure where the disconnect is on your computer.
Right. Yeah. So quick question for you. So the idea here being you've got multiple people that are working on a given project, and one of them could be working on Windows, one of them could be working on Linux, the other one's on a Mac, one of them is working with some, and one of them is working with Python 3.2, and one of them is working with Python 3.6, and there's all these differences, right, about their machines and the various dependencies and software, et cetera, that are installed on their individual computers, machines. And so the idea of Docker is that we create an image or like a container or a box, like you say here with this, that contains everything that is needed to run this application or this environment. Is that correct?
Yeah, no, that's absolutely correct. Yeah. So
Okay.
and even, it doesn't necessarily have to be a group thing. I have to be honest, I use it for every single project just on my own.
Okay.
Just to help maintain separations because uh, going to school and doing different projects with my friends, a lot of them required Python 2.7, so a lot of people use Python 2.7. And so, how do you install that onto your system and maintain all of that? So it's nice for everybody. But yeah, your explanation was exactly right.
Okay. Cool.
Yeah. Uh, and also, too, I wanted to bring up is a lot of people, when they talk about Docker, a lot of them talk about VMs, which is also sort of a nomenclature for virtual machines. And I just want to clear that up. So, a lot of our audience, they might not know necessarily that difference and where that difference lies. And just to show you guys a picture of that. And this might look a little bit complex. There's a lot here that you can really sort of ignore. But the idea is we're comparing three different things, right? So we have virtual machines, VMs, Dockers, which is what we're talking about here, and also just a representation of what it looks like on Windows. And I can sort of get why that's different on Linux versus Windows here in a second. But sort of directly comparing virtual machines and Linux, they actually really look really close and similar to each other. So we have, if I had a virtual machine and a Docker, I essentially want the same thing, right? I want it to run some sort of application, which is meant by app one, app two, app one, app two. You can sort of ignore the bins and libs for now. But the idea is the same in that we want to contain sort of this complex system on its own, sort of separate from our host operating system or our host machine here at the bottom.
Mhm.
And they do really similar things, right? So hypervisor is essentially what a VM virtual machine uses to sort of separate itself from the host, to sort of create that distinction between what it's running and what you're running, right? So to create that isolation. And Docker Engine is the same thing for Docker. It keeps this separation here. But what it does is very different. So a hypervisor of a virtual machine actually essentially emulates a computer, just like if you've ever played Game Boy games on your computer, you have to emulate the hardware, right? So your computer has to emulate all the physical chips on there, and it actually is a lot. It's quite a bit for your computer to emulate all that process. It's quite complex, and it has to emulate all those operations, and it takes a lot longer than what Docker Engine does. And what Docker Engine does is it works sort of hand in hand with the underworkings of Linux to sort of do that much faster. So it's not emulating an entire new computer. It's just sort of emulating the top bits and parts that it needs. So it shares a little bit more underneath with the original host down here.
Right.
Um, so it's a little bit lighter though, is the general idea. It's faster, it's easier. You don't have to have a supercomputer to run a host machine. When people talk about virtual machines, they're generally a little bit harder to work with and a little bit heavier.
And so one quick kind of maybe comment here, if
Sure.
people who are listening to this are unfamiliar with um, kind of the idea of a virtual machine, one quick and easy way to get to work with virtual machines for the first time is there's a couple of them, but what's the oh no, I just blanked the name. What's the
Like VMware, maybe?
yeah, VirtualBox.
Oh, VirtualBox. Yep.
Right. So VirtualBox is basically a piece of software that you can download and run on. Let's say you're running Windows, right? You can download VirtualBox and basically run this application on your Windows machine. And within VirtualBox, you can create virtual machines. And on one of them, for instance, you could install Ubuntu, and on another one, you could install various different versions of Windows or whatever it is that you need. And then you can launch VirtualBox, and within VirtualBox or VMware, you can basically double click on one of these virtual machines and it'll open up the entire window. Is basically like you're in a new computer, like you'll be looking at a different desktop. And if you go full screen with it, then basically it's like you're running, instead of on your Windows 10, like all of a sudden you're on Ubuntu, right? But it's just an application that's running inside your Windows machine as a virtual machine, right? So when people are first getting used to or playing around with virtual machines, using VirtualBox and just installing, for instance, Ubuntu or a couple different versions of Linux and having a few different virtual machines, it can be a great place to start.
Yeah, no, absolutely. And I've sort of been on both sides. I've used sort of a virtual machine. I've used Dockers before, and they each have their own use case.
Hmm.
So I'm definitely not one to say that Dockers replace virtual machines. Virtual machines are critical structure of a lot of different things, but they definitely have their own use cases, as we'll kind of sort of see later on.
And I'm kind of sidetracking here, but one thing that I've used VirtualBox and virtual machines for on several occasions is testing software across different operating systems, right? So like how does this app work on, how does it display on Windows, I mean, versus Mac versus Linux, etc. So on my Mac laptop on several occasions. I've had VirtualBox on there, and it has a Windows installation and a Linux installation, and so I can very quickly just open them up and test whatever it is that I'm doing and make sure that it runs well on that OS as well.
Yeah, yeah, that's a great use case for virtual machines. You're exactly right. And so that's kind of where we get into why does Docker look different on Windows, and that's kind of just to what you said, and a little bit to what I said is Docker works really hand in hand with Linux. Sort of some of the capabilities that Linux has aren't there with Windows, not because Windows lacks in capabilities by any means, just because they're built differently and how they talk to the hardware. And so essentially, you actually have to install, like you said, a virtual machine on your Windows desktop that allows you to have Mac or have Mac OS or Ubuntu or Mint or something on CentOS. And then in that, they install Docker. And it doesn't necessarily feel like VirtualBox, right? You're not going into a front end like another computer like you would with
Mm-hmm.
VirtualBox. But it just sort of creates this light sort of backend Linux that allows you to run Docker on Windows. If anybody's ever done that before, that's how that works.
Got it. And then, so just to maybe clarify and summarize, the primary difference between the way Docker works and a virtual machine works is that a virtual machine is truly, maybe not truly, but almost entirely isolated and separate. And like you said, it has to emulate all of this entire operating system, whereas Docker uses the existing underlying Linux, ideally, operating system without necessarily needing to be completely separate and emulate so much of the operating system.
Yeah, no, that's absolutely right. So when you make a virtual box, you choose your CPU, you choose how much memory you're going to give it, and because you have to emulate all that. Whereas
Mhm.
Docker, you're like, oh, yep, I just want CentOS or I want Ubuntu or sort of
Got it.
what have you.
Sweet. I'm excited to learn more.
Yeah, definitely. And sort of into that, I sort of want to jump right into that of we sort of know what Docker is and sort of what sort of problems it solves. We want to contain all these complex systems. So I want to jump into that. So if I was a new user of Docker, how do I get into it? How do I find Dockers, maybe sort of off the shelf that I can use, and I don't want to make my own Docker? And if that doesn't work, how can I make my own? So I'll stop my screen share here and share the another part. All right. So all I've done here is I've gone to Google or sort of whatever your favorite search engine is, and I looked up Docker Hub, or I just went straight to the website hub.docker.com. And this is the front end of this, and you can sort of sign up if you want. So create an account. I think that's for uploading your own Docker images, right? So if you created a really cool Docker image and you want to share it with your friends, and you want to put it up for the world, you can put it up that way. But I just want to sort of really simply go and say I want a Python Docker. I work with a lot of Python and I want to run some scripts. So it immediately pops up and says, oh, I know that. So the official makers of Python actually make their own images, and they've been doing it for a long time, and they do it very often. You can actually go to the tags, and so the last one they put up here was 20 hours ago. So they're really on top of keeping them updated, keeping them safe, secure, keeping them sort of with every update that they make to Python, making sure that there's the Docker image right alongside of it.
Nice.
Yeah, so if we go down here, it just gives you a bunch of helpful little sections. So like simple tags, just kind of gives you idea of some of the updates that they've made and sort of the versions of those. And
Is each one
uh,
of these, do you call it an image or a container?
yes, so there's definitely a distinction there. So when they're in this format, and we'll get into a little bit more, they're called an image.
Okay. So are these all images here?
Correct. Yeah. So each
Got it.
one of these is an image, and I can see if I can zoom in a little bit, maybe make it a little bit more easier to read. There you go.
Nice.
Yeah, so it's a 3.7 Buster, 3.7 Stretch. Those are each an image that you can pull down.
Would you be expected to kind of understand the distinctions between any of these, or if you're the first time user, should you just pick one?
No, as a first time user, even I don't know what these are. Like, what's the difference between 3.11 Alpine and 3.12, or what does RC mean? Those are definitely things you wouldn't know without tearing through their documentation. And even up here, they say you can just pull Docker pull Python, and that'll
Got it.
get you where you're going. Um, some of these other ones are sort of the distinction of maybe they have a little bit more to them. Some they have slimmed down versions too that are smaller. So maybe instead of 3 or 400 megabytes, they might only be 20 or 50.
Okay.
So there's a little bit of difference there. Yeah. And going down, they actually will get you some documentation, sort of, what is Python, how to use it, sort of if you want to make our own Docker file, which we'll look into a little bit later, or running just a single Python script, right? So if we don't necessarily want to have the whole Docker file and we just want to run one simple script, this is the perfect way to do it. It sort of gives you these instructions, and I'll sort of walk through those with you. But I'll share my screen over to sort of a command terminal, and we can see what that looks like to pull down a Docker image and sort of play around with it and find ourselves in the command line of Docker and sort of what that looks like. Perfect. Okay. So I can come here and I'm at the command line. Can you see that okay? Everything all right?
Yeah, looks good. And so
Perfect. Okay.
what is this VS Code? Yeah.
Yeah, yeah. So this is VS Code, and I've gone
Yeah.
back and forth. I used PyCharm for the longest time, and then I switched to VS Code after a little while.
Cool. So the basically the IDE, the editor, the screen that we're looking at right now is an application called VS Code. If you're not familiar, it's super useful for lots of different languages, and you can use the terminal right here at the bottom, which is great.
Oh, sorry about that. I have some cats in the background, but yeah, yeah. It's VS Code's really helpful. I fell in love with that. I've been using it professionally. Also for my own projects. It's a great tool and a great IDE to work with.
Nice.
Yeah, so I just created a little directory for us to work in. There's not a ton here. I have a simple sort of hello world script, so you can see that there's not a ton in it, right? It's just, a little script that prints hello world. Other than that, we're in a clean slate here. So if I wanted to pull just a simple Python Docker, it would just be Docker. I think it's pull and Python. And I might already have this image, but let's see what that does.
And this
Yeah,
assumes too that Docker is installed on your machine, which gives you that Docker command.
absolutely, yeah. And also a thing too is they give you an extra ability to sort of not have to have sudo or type sudo before using Docker. Docker requires sort of those elevated privileges that a root or a sudo or admin account would have just with
Mhm.
sort of the things it does. But yeah, that's all. I have it installed and I'm using it at the command line.
Nice.
Yeah, and sort of to go over what happened here is so we told Docker, I want to pull an image, and that image's name is Python. And it said, okay, well, you didn't give me a tag, right? So we could have put Python um, hyphen 3.7 Buster, right? We could have used one of those crazy tags and said, I want
Got it.
this specific one. Or we just said, hey, pull Python. And it says, okay, I'm just going to pull the latest one. And
Mhm.
they tag it in the repo as latest. And it says, okay, I'm going to go and pull it from Docker repo is the default place. And it says, all right, I'm going to pull all these things. And none of these really have great human readable names, right? Like I can't tell what this is. All I know is it already exists for some reason on my system. And what these are is what's called layers. So when we look at Docker files later on, layers are essentially what breaks up are broken up by commands. So when we write a Docker file and we say, "Hey Docker file, I want you to do this in the Docker for me to create my image," it breaks those up into layers and chunks. And this will sort of make a little bit of sense. I'll tie it back later when we go in to make our own Docker file. But just suffice it to say that it breaks up a Docker image into these Docker layers, and we can see that it shared them with something else, right? So this already existed before because I have something else that maybe shares these same layers as this Docker image. But there's also some different ones that it pulled down, and it's just saying that that it pulled and it downloaded the newer image, and it's ready to go.
So
So
does this add, like if we do an ls again, does this add anything to the directory that we're currently in?
no, no, it doesn't. So if we do
Okay.
ls, we still have the same thing. So my hello world and a few folders and files, but yeah, nothing was added by the Docker. And sort of go and see like, okay, I have this image. where did it pull to, right? So we can do Docker. Here, I'll clear out the screen a little bit for everybody. If I do Docker images, I have a ton. As you can tell, I have an overabundant amount on my computer that I need to delete. Let's say there's Python 3.7 Buster. This is the one that we just pulled, right? Python latest is the tag for it. And then it said it was created about 3 days ago, is whenever they pushed it from Python's developers. They built it, pushed it to the Docker repo, and it has a size of 934 megabytes. So it's by no means a small image. It's almost a gig. But that's kind of where you see those other ones. Alpine specifically is a really small version of Linux that they use to build really small Docker images. You can see them be, 57 megabytes isn't uncommon for
Mhm.
those small ones. But you'll go into those Docker files and you'll be very bare minimum. Like you won't have Vim, like you won't have a text editor, you won't have a lot of things that are common to a lot of people that are familiar with the command line. And you
Right.
often install that, and that sort of negates the reason for making it bigger. But it does work. It
Right.
does have its use case. Yeah. And so this is kind of where we get this distinction of images versus containers. So right now we have a list of images, and none of these are actively running. They're essentially boxes that aren't they're just not turned on, and they're sort of sitting at rest. So if we wanted to use one of these, um, you use a command. It's called docker run, and this has a bunch of different commands. And we saw this earlier with how to run a single command on the Python Docker repo. It's rm essentially says I want to run this image into a container, and after I'm done, I want you to clean up the container because those will sort of sit around and waste memory if you don't do that. And
Is,
then
is that what the RM is? Remove?
correct, yeah, I think that's shorthand for remove.
Yeah.
And then another common one you'll really see is it, or sometimes ti. It's the same one. They're actually two separate ones. One's dash I and one's dash T, but you see it combined. And what that essentially means is interactive, or you want to see it on the command line. So if you have if I wanted to run bash inside of this, and maybe that's what I'll show us, is I want it to be an interactive session with Docker. I don't want it to sort of go off on its own, execute what I told it to, and then just disappear. I want to actively see what it's doing and maybe
Mhm.
actually interact with it myself.
Got it. And this is a totally tiny question, but why does the
Sure.
RM have two dashes and the IT have one?
I think it might just be RM that's the full name of RM.
Okay.
Um, it's been a while since I have to apologize. It's been a little while since I've looked at the documentation for Docker. I
Mhm.
think it's just second nature for me to do two dashes
Okay.
at this time, but I think it's because you might be able to even shorten RM to like dash R. I could be wrong. That's
Mhm.
usually the syntax for command line interfaces is two dashes for the longer full name and then one dash for a shorthand.
Got it.
Um, but yeah, like I said, I have to apologize. I don't know that off the top of my head.
No, that's cool.
Yeah, and so then I want to say, okay, well, what image do I want to run? Or image. I want to say Python, and we just pulled the latest, and I'll actually list the ones that I have. So I have latest, 3.7 Buster, 3.6 Buster. So we just pulled latest. I want to use the latest one, latest and greatest. And then you could say whatever you want. So maybe I want to run Bash, and I think that's all you have to tell it. Yep. So now we're in some sort of command line interface. It's clearly different than me, right? So you don't see my name anymore or my computer name or the
Mhm.
path. It says we are root at some sort of weird sort of commit here, and we're at the root. So if I do ls, I'm at the root of some server, and I can ls in the home directory, and my stuff's not there. So it's actually a different file system entirely. So I'm inside of that image that we just pulled. So we can
Mhm.
do all sorts of nasty things in here and not have to necessarily worry about it. So we can sort of remove the root directory, uh, and maybe the lib64. Why not? Um, and this would just totally, yeah. So we can't even, yeah. So it didn't even recognize ls anymore after I've
Mhm.
removed lib64. So that's the nice thing about Docker is, sort of a thing that I've picked up as a software engineer. You want to be able to fail early and fail safe, right? So if I mess around with this Docker and I delete a bunch of things accidentally, I don't want that to ruin my system. I don't want it to ruin my team's code. I want to be able to fail safely without having to worry about, you know, what we're developing.
Hmm.
Yeah.
So
Um,
now that you've destroyed that, can you just restart it and it'll be back to the way it was initially, or do you have to kind of pull again?
no, yeah, it's good to go. So what happened there is we said we want to run this image, and it put us into a container. So it took that
Mhm.
image and said, okay, I'm going to make a container from this image. So our image is still here. If we go and look at it, Python latest, it's still here. It still says it was created about 3 days ago. So everything's sort of wiped clean, the whole slate. So if
So
we
anything you do when you're inside the container does not affect the original image.
correct, yeah, and
Okay.
and there's actually, and I can show the command for that. You can actually edit an image and then commit it, or edit an image as a container and then commit that container as a new image if you want. So let's say um, you did some really cool stuff inside of a container, but you don't necessarily remember all of it. You don't want to lose all that progress, so you can commit that into an image. So you can go into that and make that image and sort of repeat off of that.
Got it.
Yeah, yeah. So if we go back into here, um, everything's good to go. So we have root again, lib64, I can ls again, and it's all clean. So nothing's broken, which is
Nice.
really nice.
Yeah.
Yeah. And we can sort of see that container, right? So, or that command that they gave us on the Docker Hub repo for Python. Let's just say I just want to run my hello world script. That's all. I just want to run one Python script. I can run it through here, of course. But did that run in Python 2? Did that run in Python 3? Ubuntu defaults to 3.6, I think now. Maybe I want 3.89, for my friend Ryan, me and him are working on a project and I want to run it in a different Python. So how do we do that in that container, right? So they did give us that command and I have it up here in this top right corner and I can type that through again and sort of explain what I'm doing here. And it's definitely a lot to take in. And there's definitely times that I have to go back through and sort of look through the documentation and be like, I want to do this. How do I do that? What's the command for that? So this is the first time we're going to see this. It's called -s name, and that's really simple. It's essentially saying I want to name the container something.
Hmm.
And I'll show you what difference that makes because we haven't seen necessarily these names. This will still be random. I don't think that changes with this command, but I'll show you what that means. So let's say it's the Python hello world, and then this next command is -v, which stands for volume. And we're essentially saying, I know that Docker is isolated from my system, but in this case, I really want to share something with Docker. And in this case, we want to share my Python hello world script. So I want it to be able to execute that. And to do that, I have to get it into its system because otherwise it can't touch anything in my system.
And
So
volume in this case is not about like decibels, but volume as in like a disk
Y-
volume.
exactly. Yeah,
Yeah.
it's essentially saying I want to share this file or this directory or something along those lines.
Got it.
Yeah, and this is just straight out of their documentation. I think it's just because this is where they default to. So I didn't choose this by any means, but they're saying you want to mount where you're working right now, which is my home directory, VS Code under Docker Nomad. So I want to share that, but I don't want to put it in the same folder on the Docker. I want to put it in /user/source/my app, and that's just where they said that they wanted it in their documentation as a quick example. And -w is workspace essentially, where above here you saw me enter bash and it put us at the root.
Hmm.
-w is saying I don't want to enter at the root. I want to enter my main entry points. I want that to be a different folder. So when I enter the Docker, I want it to instead be where I just put that new folder in mine. So I want to put it in my app is when I'll actually enter the Docker.
Okay.
And then same thing, Python latest, and we can autocomplete that with a tab if you have it installed. And we want to run Python inside of that container. and we want to run our hello world.py. And this should work. Let's see. Yeah, so we saw hello world. To give you an idea, the Docker container image stood up as a container. It said, okay, I want to put this folder inside of this area of my Docker container. It puts it in there. It also says that my workspace should be this. So when I stand up this container, I tell it to do Python, it's already in that folder. And
Mhm.
so it says, okay, I'm in /user/source/my app, and I want to run Python over this hello world file, which we included because we volume or folder mounted um, this directory that we're in. So essentially, if you had done this, docker talk.md hello world.py and trial would have been in there. So, and to sort of make that clearer, it takes a while to sort of figure out what that means and how that works. We can actually go in here with bash, um, and instead of going into root, we came into user/source/my app. And if we do
Mhm.
an ls in here, we can see all those files.
Nice. So quick question on the when you say -v, do you always run this command from the directory that you're that you're currently in, right? Or is there a way to say, because from the command line you can kind of do anything from anywhere, right? So can you say -v and then a path to some directory on your computer, or are you typically always just in that directory?
I've seen it both ways. I think the way that they have that command written is it has to be an explicit path. And what I mean by explicit is you can't use a shorthand with where your directory is at. So, sort of as a demonstrative, I can use cd or ls dot dot, which means not my current directory, but my parent directory. So user/source, and it shows, okay, my app is in this folder. You can also do ls dot, which says I want to do my folder. Um, you can't do that with that command. I'm pretty sure you have to say /user/source/my app.
Hmm.
So it's a little bit difficult too. So I would say usually you have to have a common place where you'd pull this down to, or something along those lines. Like you'd always expect this folder to be at a certain place. So if I gave you to this Ryan and I gave you like a script or a command that ran this, I would tell you, you just make sure to change this or put it in this similar folder, put it in your root or your home directory or something along those lines. Um, but
Got
yeah,
it.
hopefully I answered your question.
And so the $ $PWD there, basically what that's doing is printing the working directory, the current directory. So it's saying -v mount the and the path to the volume that it's actually mounting is PWD on
Yeah,
but on your previous, like when you were outside the container. Yeah.
yeah, you're absolutely right. Yeah, so yeah, it's just a shorthand variable that exists saying that where am I? So I'm in
Yeah.
home, Medina, VS Code, Docker Nomads, and so it replaces this PWD with that full explicit path from all the way from the root all the way to the folder that I wanted to include. So you're exactly right.
Got it. I see it now. So it's basically saying the PW is printing this current directory. So it's saying mount this current directory into the user source my app directory in the container.
Yep. Yeah.
Got it.
Exactly right.
Got it.
Yep.
Yeah.
Yeah. And kind of get an idea too to sort of show you why, maybe a little bit cleaner, why people put -srm and sort of what the name part comes into that. So let's just say dash, actually, yeah, -it, um, Python and bash, and this will put us into Docker. Uh, and I'm going to use a VS Code here. I'm just going to say I want you to open a new terminal, and I want it to open it up sort of right where we're working again. So I still have this other one open. It's still inside Docker, still inside that root area since we didn't do any special command lines this time. And I want to run some Docker commands here. So I want to say Docker, I believe it's PS, if I'm correctly. And yeah, to forgive me again, I don't remember what PS stands for, but essentially it's like listing the containers that are running. So if we click this, we can say, okay, container image command, create status, ports, and name. So we can see that there is a container that's running right now with an ID. That container's image is Python. we ran bash. It was created 35 seconds ago, and it's been up for 34 seconds. We're not sharing any ports. We can share ports just like we shared folders. And it has a name called determined Shamir. Those are just randomly generated names to make sure that if I have, a Python one or um, a Plex server one or a database one, they don't have the same names and those don't sort of clash. Um, so they randomly generate these unless you pass in that dash dash name.
Got it. Yeah.
Yeah, and so the RM, when we exit out of this Docker on this other one, you'll see it close out. And since we didn't add the dash dash RM, you won't see it in here, right? So if we do docker ps dash a rps, you won't see anything. But if we add a dash a, you'll see that it's still there, but it says that we exited 0 seconds ago. So it'll actually sit here and take up memory and not do anything. So a lot of times people will add the dash dash rm, just say, hey, once I'm done with this container, clear it out because I'm not gonna keep it around for any reason.
Got it. And then if you forget to do that, yeah, how do you get rid of one that's been exited? Or
Yeah,
how do
no,
you
good.
shut it down?
That's a good question. Yeah, so it's just docker system prune, and it'll give you a warning. So it says this is going to remove all soft containers, which is exactly what we want to do. And the rest of these are a little bit more difficult to understand, sort of dangling images, build cache, but essentially sort of artifacts of, let's say we were building a container or doing something that maybe we left some extra layers around or some extra intermediate sort of images. It'll clear those up too. So this is a pretty safe command. You don't usually have to worry about running it. Um, it's run pretty often. And so it just says, okay, hey, I cleared out this image and it matches most of what this one was, right? So 5027E, 5027E, just sort of shortened it up here in this PS. So we deleted it and we claimed about 8 bytes of space back from that.
Gotcha.
Yeah. So yeah, so that was a really sort of a whirlwind through Docker commands. But I wanted to sort of give you a really brief way of, I have a simple script and I want to just run it with something off the shelf. I don't want to necessarily make a full Docker file. But I would love to show you guys next of maybe the Python off the shelf mounting, this directory. Maybe I have something a little bit more complex and I have, a need for maybe not only Python, but maybe I want to install some other things in there that aren't Python.
Hmm.
Um, you're not going to find the exact image out there already for you. You can make your own. I would love to dive into that.
Let's do it.
Awesome. So yeah, I'm just gonna come over here into VS Code, and I want to tell it. I'm gonna make a new file. And you could call this whatever. The Docker nomenclature usually is Docker file, just literally Docker file, not an extension,
Okay.
um, which is kind of annoying. So, so like VS Code, it has a lot of extensions, like you said for Python. Like it recognizes hello world.py is a Python file, but if you name a Docker file as anything else, or if you give it an extension, it immediately doesn't recognize it as a Docker file. So if you have anything that sort of helps you autocomplete or do anything sort of those niceties, those all go away. But usually, if you just have one Docker file and you call it Docker file, it's all pretty good.
Gotcha.
Yeah. So let's say we wanted to make a similar one to Python. So let's say we want it to come from Python, right? We want it to be based off of that. So we're going to say from a different image, I want to pull and base my work off of. So we can use that same one that we pulled down. So I want to use Python and I want to use latest. So what this is saying is I'm making a new Docker image and it's going to be based off of Python latest. And that's kind of what Viola or Visual Studio Code is highlighting and saying, hey, this is setting a base image for you to build off of in subsequent instructions. And then from there, we will use a command called run. And what this is saying is, okay, I have my Python latest container or this image, and inside of it, I want to run some commands. I want it to tell it to do some things. Like I want it to install a few applications. I want it to go out to apt-get and I wanted to install or pull something down or curl something from the web, sort of whatever you want. And it's really close to Bash, if anybody's used that, or Shell, PowerShell, and it's really similar to that. You can sort of type pretty closely in there. There's a few things that don't necessarily go all the way across. A few uh, sort of edge cases that you'll hit that you have to sort of watch out for, and you'll hit those errors. But it's pretty intuitive if you know Bash, and that's essentially what it's saying is go into execute commands inside of a shell that's inside of this image that I'm basing off of.
Right.
So
Makes
let's
sense.
say if I, yeah, oh yeah, if I wanted to, I know I have Python. I think there's pip in there. So let's say I want to pip install Flask. I want Flask to always be inside my image all the time. So we'll do a run pip install Flask, and we can add more to this or do anything like that. But just to get like a idea, and I'll make sure real quick that our original image didn't have Flask. So I'm just going to go into Python and say, hey, did you have Flask? No. Okay. So it's saying it didn't have Flask. So we'd have to um, install it right here if we wanted to use it. So I'm telling it to go out, find Flask, install it. And so if I go back into Python, like I said, sorry for the noise. I do have some cats in there,
That's perfect.
energetic.
No problem.
So if I go in here and I import Flask now that I've installed it, cool, we have no problem. But I don't want to do this every time I create this image or every time I create this container. So I want to make my own Docker file that I can sort of have all the time. I know it's going to have Flask ready to go. Um, so if we go into here, we can see that I have that Docker file. My hello world is still here. So now we're going to use a new command we haven't seen yet. It's called Docker build. Uh, and thankfully, it's a little bit simpler than the other ones we've been using, which is nicer. It's less -srm and a bunch of different things you have to type in. So if we do Docker build, and then I'll just do -f, and that's essentially saying I want to build with a certain file, um, and I want to use my Docker file, and then maybe I want to tag it. So when we downloaded those other, we downloaded Python latest, we downloaded Python 3.6 Buster. What we're saying is I want to name this something. So rather than just Python, maybe we'll say Docker Nomad. And we can also tag it here as well. We could say 1.0.0, or if we could tag it latest, but it'll actually do that automatically on its own.
Okay.
Uh, so if we do that, and then the last thing you usually add is a dot here, and the dot, or this last thing that you enter here, it could be 2 dots, it could be 1 dot, it could be a file path. What it is, it's saying it's actually called the context. And it's just essentially saying, where do you want us to run this command or this Docker build command? So I'm telling it dot because I want it to run in this current area that I'm at. So the VS Code, Docker Nomad. Because sometimes we want to copy stuff from our file system into this Docker image. So you might need to tell it, or you might want to do that from a different directory rather than the one you're currently in.
I guess I still don't totally so the dot, is it not saying where the Docker file is to execute, or like, does it really matter where, in what directory a Docker container runs?
It does. So it's kind of weird that you can do both, right? So I could technically be like in a third folder that's different from where my Docker file is and where I want it to work. So I could be in, say, /home/Docker files, and let's say I had a giant folder of just Docker files, um, and I want it. That's where my Docker file is. So I can do a -f to that, and then to give you sort of a idea of what copy looks like, you just say I want to copy, um, let's say hello world.py into the root or something along those lines, or into /temp of the Docker image that I want to make.
Okay.
So maybe we're not in where hello world is. So we would say instead, I want that to be under /home. I don't know if it'll, yeah, /home/J Medina, VS Code.
And you're saying that's where the hello world.py would be for it to find and copy into /temp.
Yeah, essentially. So it's saying, here's my doc file. It's over here. And then as you're running these commands, if I tell you to go look for files, that's really the only time it matters.
Right.
Use this area. Go look in this area for those.
Got it. Yeah.
Yeah. So it is a little confusing, and I've definitely been tripped up. Like it's it's a trial and error process
Mm-hmm.
sometimes to figure out the volume mounting or the context. And there's definitely been times I go back and forth, and I build an image that takes a lot longer to build, and I'll go into it and I realized I copied the wrong directory, or I copied the child or the parent directory, and it's like way off and way wrong. So I have to go do it again. So it's definitely a trial and error thing, and it's just something, it takes a little bit of practice, but it's not too bad.
Yeah, like with all things software development, it's usually not very intuitive, and it takes practice.
Yeah, absolutely. Yeah, and I'm just going to comment that out. I think
Cool.
that's right, but there might be something else here. I can't remember, but yeah. So I want to build this Docker file with Dockerfile. I want to tag it Docker Nomad, and it'll tag it as latest as well. And I'll put a dot just saying that I want to do it in this directory. So it's saying, okay, I'm going to send the build context, which is saying sending this directory. I don't know why they call it that. Maybe it puts it into the same file space. I'm not too sure. And then it says step 1 out of 2, I'm going to use from Python. So it's going to say I'm pulling that image, and we already have it. And that's what this is. And then I'm going to run step 2 out of 2, which is run pip install Flask, which is exactly what we wrote. And you can see all of what that command looks like. So it collected Flask just exactly like we did in the container, and installed it, did it successfully. And you can see some other comments in here like root remove intermediate container, um, which is kind of what I talked about earlier with those dangling containers. Sometimes these can be left around um, and suck up memory. And so it says, oh, it successfully built it, and it successfully tagged it as Docker Nomad latest. So if we do Docker images, we come back up here. I built one earlier called Docker Nomads, but here's the one we just built. So it's Docker Nomad, the latest tag, and we built it 55 seconds ago, and it's 943 megabytes, which is really close to what the original Python one was, which was 934. So it looked like Flask took about 10 megabytes to install, which is actually really surprising. but but yeah, so you get this idea of we built this new image out of an existing one, and adding something in here. So if we go into there, yeah, I can clear this off for us a little bit. Kind of going back to the earlier command. So rather than running Python, the original image, I want to run Docker Nomad, which is the one that we just built. And I want to get into it with Bash. It looks just like the other one that we just were using, but if I instead use Python this time and I import Flask, we shouldn't have any issues. So it's good to go.
Right. Nice.
Which is really nice. So now, I want to come in here. I want to use Flask all the time. I don't have to install it all the time. So you see this a lot in professional software engineering, where I maybe have to give a company a fully working service or product, and they don't want to have to worry about installing all of its dependencies and making that work with their system. Like I could just give them this box, and in this case, our dependency is Flask, and it just works for them. They don't have to worry about what's on their system, having a network issue if they can't install it. Maybe it's too big. It's just ready to go.
Mm-hmm.
Let's see. And that's generally probably, I would say, 90% of the commands that you'll need with Docker. Like I said, I can show you guys the copy if you want. But yeah, I would say that's, like I said, about 90% of what you'll use is those few commands there, and just a general idea of sort of coming into a Docker file and building off of it if you need
Yeah.
it. And there's always more to add to it and more you can look into it. But I would say that's to get somebody up and running. That's all you need.
Nice. Super cool and super simple. I mean, it's obviously it's I'm sure it's a rabbit hole of complexity, but in order to just get started, well, one question for
Oh,
you,
sure.
so let's say that I want that image on my machine. Um,
Sure.
how do we, how do you go about sharing an image? And a follow-up question on that is, because there's that Docker Hub, but then is it all public? Can you have like private images on Docker Hub?
That's a really good question. So I can actually show you some commands if we want right here. I can show you some commands
Yeah.
to once we have a image and we've made a container out of that. Now
Uh-huh.
I want to give that to somebody else. What does that look like? And I might have to look it up. I think it's Docker save, and we might be able to pull it up on the command line. Um, and I can go into that. We can look through that together. And then the answer to your second question is private versus public. So that's a really good question because we work a lot with that in the software world, right? So if I create a product for somebody, I want to give that to my customer, not necessarily the world. I mean,
Right.
if you're working on open source, it's a lot different, right? So if I want to give Python to everyone, I can just upload it to Docker Hub. Um, with private repos, anybody can have a private repo. You just have to find essentially the right software to host it locally or within your own company. So if coding nomads wanted to have their own Docker repo, what I've used at previous companies is called like the Nexus artifact repository, and it's a free open. I don't think it's open source, but it's free software. You can essentially start up a little server that can host a bunch of things. It can actually host a Pipey repo. It can hold like a Python package repo. It can also hold Dockers. It can hold raw files, zip files, configuration files, and you can actually share Docker images right through there, just like you would with Docker Hub. So you can actually Docker pull and Docker push right to that, and then once you push your image up to your private repo, your coworkers can go and do Docker pull right from that and get the same image. So
Got
that's
it.
really nice.
And kind of a random follow-up question, but how often in your work are you sharing images and working on shared images, versus how often are you kind of just using it personally?
I would to me, I would say I am the Docker person at work. So
Okay.
I would say 100% of the time I'm working within Docker at work and uh, just personally, because I bring my own laptop to work. And even for people that have their own work computers, it's still just anybody that's had to wrangle Python packages.
Hmm.
You can use virtual environments, but I've had that fail on me. You can use Anaconda, but it's a little bit harder, a little bit heavier, and still you sort of run into some issues. And then just installing stuff to your system, it just creates issues. So I've always been an advocate that it takes, maybe 30 minutes to get up and running with Docker, at the longest, if you've never touched Docker before, to just get an idea of what commands you need, finding the image you need. And yeah, we share containers all the time, and that's how we deploy. And that's how a lot of companies these days are deploying is putting their application into these or making services out of Docker. So rather than an application running on there, maybe you have sort of an interface that Docker container provides on the internet. Maybe it's a website or something along those lines, and it's all contained in there. So yeah, I said it's definitely taken over my work and private life.
Yeah, nice. Yeah, I'm definitely gonna use it some more on my machine just to get more comfortable with it. And, another kind of maybe kind of a closing out question for you is, are there any kind of gotchas or things to look out for or common mistakes that you see people making, or like kind of
Uh,
pitfalls or something to avoid? For instance, the first time I teach somebody the rm-rf command on on the CLI,
yeah, definitely.
I always throw out, be very, very careful where you run this and make sure you know exactly what you're deleting, because it's a powerful command that can erase your operating systems.
Yeah,
Is there
definitely.
anything like that in Docker?
Yeah, absolutely. So I'd say the biggest gotcha that I had for the longest time and that I see every day with people is so you got to be careful with this copy and the volume mounting. So they're very much not the same thing. And you see a lot of people sort of have that question of like, okay, I have this separation of my stuff and what's in the Docker. Um, and so let's say I wanted to work fully in Docker, like maybe I want to use like a command line text editor like VR VM to just make like a quick change
Hmm.
on inside Docker, does that change what's outside of the Docker? And so that really depends. Like if we copied hello world into there, that would not change. So if I made a change to hello world and I said hello world exclamation points, or hello world period, that change will persist as long as that Docker file persists, is if we copied it in. But if we volume mounted it, it'll actually change the file on my host, so I don't have to change it again later.
Got it.
Um, so that's a really big gotcha of figuring that out and sort of making sure you're on your toes, because there's a lot of people that are like, I'm going to change things outside the Docker, but I'm not seeing anything change inside the Docker. Like, what's wrong? And it's like, well, you're changing it, but the file that you copied in, that's still the same file, the original one that you copied in that doesn't have changes, or you make a bunch of changes inside the Docker and then you kill the Docker and you lost all your work. So
Right.
that's the biggest gotcha I've seen, and a lot of people get frustrated. But it's just making sure like you can run sanity checks. Just if I edit it inside the Docker, do I see that change out here? Or if I edit it out here, do I see that change in the Docker? And that can, it's a 10-second check, and it
Yeah.
saves you a lot of headaches.
Right. And then, so would you generally recommend, like in this one small use case, would you generally recommend using volume mounting rather than copying? But I guess it's a case by case use case kind of situation. But do you typically um, do the volume?
I'd say so. My preference is usually in development. If I'm not deploying, I usually try and volume mount stuff so I can edit it out here and then run it and not have to necessarily rebuild it every time. Because if I
Uh-huh.
do copying and that's how I depend on it getting inside of Docker, then I have to rebuild it every time I make a change to see
Got
that
it.
change inside Docker. Whereas if I volume mount it, I can see that instantly. But whereas if you deploy, you might not want your code on the other system. You might not, you maybe just want a clean box. You don't want them to have your files. Like if I want to share this cool thing I made with my friends, but I don't necessarily, want my files taking up their directory or their home space, or maybe they accidentally delete it, then it doesn't work. So that solves some of that issues if you just copy it.
Nice. Well, this has been great, Julian. I really appreciate you taking the time and sharing all your knowledge with us. This is super useful, and I know that Docker is, just widely used. It's kind of taking over the world, just like it kind of took over your day-to-day work life.
Sure.
And a lot of people always have questions about it. So this is a fantastic and super useful, I'm sure, for many people. So thank you again for your time. I really appreciate it.
Yeah, and thank you, Ryan. I appreciate you having me on. It's been great.
Nice. Well, anything else you'd like to say before we close out?
No, I guess I would just like to say to everybody, Docker, just like anything else in the world, it looks a little scary at first, but I would say for me, as somebody who tinkers a lot at home and works all day at work, it's benefited me quite a bit. So I
Mhm.
mean, even if you get in there and you absolutely hate it, it's just an experience to have.
Right.
So I would say, even if you dip into it, go for it.
Nice. And then obviously you can follow up this video. At Coding Nomads, we would love to make more, and we plan to make more resources around Docker, and videos and tutorials. But the next step for me would be to make sure Docker is installed on my machine. Go back through this video, kind of do exactly what we just did here. But then there's a wealth of knowledge online in terms of tutorials, and websites, and YouTube videos about getting started with Docker. So that would be my recommended next steps for anybody listening. But thank you again, Julian. It's been a real pleasure chatting with you. Thank you for sharing your wisdom,
Yeah,
and I
definitely.
look forward to chatting with you soon.
Yeah, thanks, Ryan.
Hey everyone, thanks for watching. If you enjoyed this video, please let us know by liking and subscribing. If there's another topic that you'd like to learn more about, leave us a comment. We would love to hear from you. And if you want to become a coding pro, visit our website at codingnomads.co. See you next time.